Hello everybody. Today's lesson is the last template of this chapter on stoichiometry. So you're still doing stoichiometry calculations. However, today instead of going from mole to mole, you're going to go from mass to mass. Now remember that the real stoichiometry is just going from one chemical to another chemical. The rest is just converting. Okay, so let's look at the template. Okay, here's your mass-to-mass template. So you always start with the given, whatever it is that they're giving you. Oh, you can't see that. Okay, there we go. And whatever this unit is, it must go down here so you can cancel. That part's the same. Don't forget that your molar mass is where you use your periodic table to add up all of the weights of every single element. And then, of course, that goes to 1 mole. Now, whatever this mole is, whatever that unit is, goes to the bottom. Anytime you have that mole to mole, these numbers come from the coefficient in that periodic, in that equation that they give you. Okay? And instead of stopping at the mole, you're gonna get rid of the mole unit, and you're gonna get that molar mass. Okay, so let's go ahead and do an example. Here they're giving you 12 grams, so that's my given. And you're looking for grams of silver, okay? So the 12 grams are here, and I'm looking for the grams of silver. So don't forget, your given always goes on that first square. So 12 grams of copper go right here. Whoops. Okay. So now, because you have copper right here, that means it must go down here so you can cancel the copper. And these grams are going to come from your periodic table because you're going to have 1 mole equals copper. That always gives you your molar mass. So if you look at your periodic table, your copper is 63.6. Let's go ahead and round that off to 64. Okay. Now that allows you to cancel off the grams. And now you have the moles of copper. But you want silver. So to get grams of silver, you must have that mole. So right here, you're going to do that mole to mole thing. Okay. Because you have moles of copper here, that means you have to have, let me write it in black, mole of copper down here. And what you want is the mole of silver, so mole of silver must be up here. Okay? Now, we get these from the coefficients from your equation. So silver, your mole here is 2 because that's your coefficient. So that's going to go here. And what's my mole for copper? Now remember, it's copper by itself. When there's no number, that means your coefficient is 1. So you're going to have a 1 here with 1 mole of copper. This will cancel out the mole of copper. And now you have your moles of silver. Okay, but your equation did not want moles. They wanted grams. So you have to cancel out this mole. To do that, you have to put it at the bottom, a mole of silver. Remember, 1 mole of anything will give you the molar mass of that element or that compound. So now you're going to look at your periodic table, and silver weighs 107.9 grams. So let's go ahead and round that off to 108. Okay. This is going to cancel out that mole, and now you have the unit you want, the grams of silver. Okay, so to get this answer in grams of silver, remember you have to multiply everything on the top and get an answer. So 12, let's get a calculator out, and 12 times 1 is 12, so 12 times 2 is 24. then 24 times that 108 equals, I get 2,592. Check to see if you get the same thing. Now on the bottom, I have 64 times 1, so that's 64. So now you're going to do 2,592 divided by 64. This will give you 40.5 grams of silver. And this is the end of your mass-to-mass problem. You see how only that middle part is really your true stoichiometry. Everything else, you're just putting those little steps that we've done before together to convert to the unit you want. Okay? So now remember, your first objective is to look for what you have, that's what's given, and then for what you want. Okay? All right, if you have any questions on the mass-to-mass, you're going to ask me during Zoom, or if you want to do some more examples from your assignment, you're going to ask me during Zoom. Okay? All right. Now, those mass-to-mass problems lead into limiting reagents. And so what is a limiting reagent? Anytime you have an equation, and so let's take this making peanut butter and jelly sandwiches kind of example, okay? If you have to make peanut butter and jelly sandwiches, let's say for a whole club or your class, and you have 3 jars of peanut butter and let's say 2 jars of jam, okay? You're going to make a peanut butter and jelly sandwich until you run out of materials. Whichever one you run out of first, that is your limiting reagent. Whatever you have left over that you have more of, that's your ingredient of excess, okay? All right, so here we go. Limiting reagent versus excess. Your limiting is the one reactant when you have that balancing equation, the one that gets used up first. That is your limiting reagent. Now, whatever you have left over, this is your reactant in excess, okay? And that's it for mass to mass. Let me know what questions you have during Zoom, okay?